is different from the regular z-score.
What? You have the NP, like it's all p hat.
It's p hat is proportion, right? And they're binomial. It's a binomial distribution. So we can't have partial anything in here. They've got to be whole numbers. So we have to check first to see if it approximates normal distribution. We do this little test. We state your claim. Which one is your HO? Which one is your HA? Level of significance. We're back to table 4, inverse norm.
Oh. Well, they're going to give us one where it says you decline it, I think. You know what I mean? If the test fails, then we have to do the problem.
Well, if it fails, we don't have to do the problem. Well, the problem is, they'll give you like a little section where they'll say, test it to see if you can do it. But the rest of them, if they're going to bother writing out the whole problem, it's going to work.
The p-hat is just like the x-bar.
The p-hat is your p-hat is from your sample, x over n. Now, sometimes your problem gives you your proportion for your sample. Sometimes it gives you an x and an n. So, say for instance, your sample is 200, and it says that your proportion is 0.10. Let's make it easy. 10. Now, if you're going to use your calculator needs an x. So you take 10% of 200. Okay. Make sure you don't put a decimal in there. You can't have a partial person. So round. And you use your rules of rounding. Round by your up or down the way your rules of rounding work. So your answer may be a little bit off from the calculator. Well, if you're going to use your calculator needs the x. And sometimes the problem gives you the x and the n, and then you need to find a p-hat if you're going to use your formula. So it depends which way you're going to go with this. And I'm fine, calculator or formula. All right, so then we make a decision like we used to. This should say if z. This should say z. If z is in the reject region, reject, otherwise fail to reject H0. Make sure you use the H0. Make sure you shade. You can find your p-val because you're a z-score table, so you can find your p-val associated with that z-score if you so desire to use the p-val and interpret. So we went through this, and we just wanted to do one more. A researcher claims, and I'm on page 390. A researcher claims that 86% of college graduates say their college degree has been a good investment. In a random sample of 1,000 graduates, of those 1,845 say their college degree has been a good investment. You want to know if there's enough evidence to reject this claim. So it used the word reject. So reject means my claim is going to be HO or HA. HO. So I know this claim is HO. My researcher claims that the proportion for the population is 86%. This is my claim. The HA is its complement, not equal to 86%. What tail test do I have? Two tail tests. So let's find your reject regions while we're here. You're going to get one Z positive and one Z negative. They will be the same one. This is your reject H0. Make sure you label. This is your fail to reject. Whoops. This is your fail to reject H0. Okay, so how do I find the cutoff values for this? Inverse norm, and I have two. Good. I have two tails divided by 2.
Is there any other way to do that without using a calculator?
Without the calculator, you can use your table. You still have to divide it by 2. And then you can look in your area to see where's 0.05 in your area and trace it back, which is worse. So inverse norm works really well, but just remember 2 to share, 2 tails. If it's 1 tail, we don't have to divide anything. If it's 2 tails, we need to share. So what do you get for your cutoff? 645 and positive 1.645. Did you cut your tail in half? Inverse norm divide by 2? Who said 1.28? Did you cut it in half? Okay, and this is failed to reject. All right, now we fill out your sample information. In a random sample of 1,845 said yes. That binomials say yes, say no, two choices. If our P for our population was 0.6, what is our Q? 14. Good. So let's start with this. I'm going to use my formula. I need to know what my p-hat is. So I have to find my p-hat by setting up my proportion, x over n. And my p-hat is 0.845. It was nice because it was based on 1,000. So we'll plug it into your equation. P-hat, remember your other z-score always said sample minus the population. Sample minus the population. 0.845 minus 0.86. Then you got to do your P and your Q. Divide by how many are in your sample, 1,000. This is all underneath that radical sign. If you put this in your calculator, you need to have parentheses around your numerator, but your denominator can go underneath the radical sign. So find me the z-score. It could be a negative or a positive. What did you get, Aaron? 367, so 370. Z-scores are back to 2 positions. Z-scores are 3, Z-scores are 2. You can always look at your table to see like which one has the 2, which one has the 3. So now we locate this. This falls here. My decision is failed to reject H0. Now, if we want to test with p-val, let's test with p-val as well. That's the area that's associated with the z-score. Look up the area in table 4 for negative 1.37. And because this is two-tailed, we have to take that area and times it by 2. Okay, so let's look this up. Let's just follow this all the way through so it makes sense to you. So 0.0853. And we're going to times it by 2. Okay, there's your p-val. We're going to test this against your level of significance. And it should have the same exact decision. And remember a two-tailed test? So you're going to divide your level of significance by 2, but you're going to multiply your p-val by 2. You have 2 chances to get it.
Where did you get the final?
I looked up in your table 4, your z-score. Here we have the z-score, we have area, which is 0.10, and its z-score we found to be plus or minus 1.645. Then we have area and your z-score. Area is z-score. We have 2 ways to look at this. Can you guys use the calc? The calc is real nice for this one. And I'm absolutely fine with your calculated steps as long as you know how to use it. One proportion z-test. So I'm here. My population is 0.86. This is where it needs your x. They gave you your x. And your n. Follow your tail. Your tail is the not equal. And calculate. There's your p-hat. There's your p-value. And it's a little bit off. We're a little bit off because of the rounding. And there's your z-score. All you have to do is do the final test. And you avoid all of this mess. So use your calc for the test. It really worked nice.
So if we do like half and half, we just show like the sketch and then draw it in and then do the calc itself. We do the calc and formula.
Yeah. You all of this. I don't have to do any of this. I don't have to do that. I get that. I don't have to do this. I can do, this could be my test, or this could be my test on my sketch. But I don't have to do any of this mess. And I don't have to look at my p-val. It takes care of the two-tail. It multiplies it by 2. You saw that it had almost the same. Ours is just in the rounding. Questions?
What are we doing next week?
What are we doing?
Like we're gonna have a program or something?
Pretty soon. Why? You only need to know about it if